Ever wondered what powers your electronic devices? The answer is PCBs, or printed circuit boards. These unsung heroes are the backbone of all your favorite electronics. From your smartphone to your smart fridge, PCBs are at the heart of it all. These flat panels are like the bustling city streets for electrons. They guide these tiny particles on their journey, making sure they reach their destinations, the components that need them to function. Just like a city's infrastructure supports its daily operations, a PCB supports the operations of an electronic device. PCBs aren't just circuit maps, though. They also provide physical support to the components, keeping them securely in place. They're built tough to resist heat, shocks, and other stresses, ensuring your devices work reliably day in, day out. So the next time you switch on your device, remember, there's a PCB hard at work. Think of the motherboard as the heart of your electronic device. As the name suggests, a motherboard serves as the mother to all other components, providing a platform where they can communicate and collaborate to create the device you know and love. A motherboard, sometimes referred to as a mainboard or system board, is a printed circuit board, PCB, that serves as the backbone of your device. Whether it's a smartphone, a laptop, or a gaming console, each one has a motherboard at its core. It's like the nervous system of the body, or the city's infrastructure, coordinating and connecting all parts to function together. Now let's dive deeper into the motherboard's components. It's an intricate landscape filled with various parts, each with a unique role. First, you've got the Central Processing Unit, CPU, also known as the brain of the computer. It carries out most of the processing inside the computer. Next, we have the memory, or RAM, random access memory, which provides temporary storage for data that the CPU uses. The more RAM, the faster your device can process information. Then, there's the chipset, which acts as the traffic controller. It manages the data flow between the CPU, the memory, and the peripherals. Peripherals like the graphics card, sound card, and network card, which handle specific tasks, are also connected to the motherboard. Storage devices such as hard drives or solid-state drives are connected to the motherboard via interfaces like SATA or M2. These components are where your files and operating system live. Finally, there are the power supply connectors that deliver the necessary power to each component. In essence, the motherboard is the central hub that connects all the different parts of a device. It's a remarkable piece of engineering that enables the complex operations we rely on every day. Without it, our devices would be nothing more than a collection of disconnected parts. The motherboard brings them all together, facilitating communication and cooperation to bring your device to life. It's time to take a closer look at the PCB. Imagine an X-ray image of this technological marvel, revealing the intricate network of wires stemming from the system on a chip, or SoC. This isn't just a jumble of metal, it's a meticulously designed highway of information. The SoC, in essence, is the brain of the device, directing data and commands to where they need to go. Each wire, like a neuron in our brain, has a crucial role to play. They transport the electrical signals, bridging the gap between the various components on the PCB. From the smallest resistor to the largest capacitor, every piece is interconnected, creating a symphony of electronic communication. And the SoC, with its embedded silicon, is like the conductor of this symphony, orchestrating the flow of information and making sure everything runs smoothly. Just like the human body, every wire and component on the PCB has a specific function. PCBs aren't just a simple piece of board, they're made up of multiple layers. Now let's dive right into the fascinating world of printed circuit boards, or PCBs, and explore these layers one by one. The first layer that we encounter is the silk screen. This is the topmost layer that you can see with your naked eye. It's where all the labels and indications are printed, providing essential information about the board's layout and the components it hosts. Right beneath the silk screen, we find the solder mask layer. This layer gives PCBs their characteristic green color, though other colors are available too. It plays a crucial role in protecting the copper traces from oxidation, short circuits, and other environmental threats. Speaking of copper, that brings us to the copper layer. This layer is the heart of the PCB, the network of thin copper lines that carry electrical signals from one component to another. These copper traces are etched onto the board in a pattern that's carefully designed to optimize the flow of electricity. Next, we come to the substrate, or the base material. This layer is typically made of a material called FR4, a type of fiberglass. The substrate provides the mechanical strength to the PCB, making it rigid and durable. Now these are the basic layers of a typical two-layer PCB. But wait, there's more. In complex electronic devices, we often use multi-layer PCBs. These PCBs have additional pairs of copper and insulating layers sandwiched in between the top and bottom layers. This allows for more complex circuit designs, better signal performance, and reduced electromagnetic interference. As you can see, the layers of a PCB are not just stacked arbitrarily. Each layer serves a specific purpose and contributes to the overall performance of the electronic device it's a part of. From the silk screen that guides assembly to the copper that carries electrical signals, to the substrate that provides mechanical strength, each layer plays a crucial role in the overall performance of the PCB. Interested in this fascinating world of PCBs? Consider pursuing a career in STEM. STEM, or science, technology, engineering, and mathematics, is a broad field that encompasses many exciting careers. And yes, that includes the world of printed circuit boards. PCB design and manufacturing is an area of expertise that calls for a wide range of skills. From electrical engineering to material science, software programming to data analysis, the scope here is enormous. Imagine being the one to design the heart of a device or the one to solve a critical manufacturing problem. Imagine the thrill of creating something that powers up a world of technology. STEM education is the key to unlocking these opportunities. It equips you with the knowledge and skills to innovate, create, and make a real difference in the world of technology. So, go ahead, dive into the world of STEM. Remember, the future of technology lies in the hands of STEM professionals. Ever notice those tiny holes in your PCB? They're called vias. These aren't just ordinary holes. They're like magical portals for electrical signals, whisking them from one layer of the PCB to another. Imagine an elevator that takes you from the basement to the top floor of a skyscraper, bypassing all the intermediate floors. That's essentially what vias do for electrical signals. Vias are created during the PCB manufacturing process. They're drilled into the PCB and then plated with a conductive material, typically copper, to create a pathway for signals to travel through. They can connect any layer to any other layer or even all layers together in the case of a through via. So, why are vias so important? Well, without them, the multiple layers of a PCB would be like isolated islands, unable to communicate with each other. Vias break down these barriers, creating a unified, interconnected system. Vias are the unsung heroes of a PCB, ensuring seamless connection between layers. Not all PCBs are created equal. They come in different designs, sizes, and weights. This diversity in design allows PCBs to accommodate a wide range of electronic needs. From your tiny smartwatch to the complex computer system, each utilizes a unique PCB design. Some PCBs are designed as single-sided, with circuitry on one side. Others are double-sided, with circuitry on both sides. Multi-layered PCBs with several layers of circuitry are used for more complex electronic devices. Size and weight are also critical. A smaller, lighter PCB is ideal for handheld devices, while larger, heavier ones are used in larger appliances and industrial equipment. Now let's talk about through-hole technology. This method involves inserting component leads through holes in the PCB, and then soldering them to pads on the other side. It's a technique that provides strong mechanical bonds and reliable electrical connections. The design, size, and weight of a PCB can greatly influence the performance of an electronic device. So next time you marvel at a piece of tech, remember, there's a uniquely designed PCB at its heart. We've covered a lot of ground today about PCBs. We have delved into the fascinating world of printed circuit boards, often known as the heart of electronic devices. From understanding the basic concept of a motherboard, the very foundation of a PCB, we've journeyed into the intricate layers of a PCB. We've seen the amazing X-ray images of PCBs and the intricate wires from the system on a chip. We've explored the significance of vias and holes in the PCB, which allow electrical signals to pass from one side to the other. And we've marveled at the variety of PCB designs, their different sizes, weights, and the importance of the through hole. And let's not forget the call to pursue STEM careers, where you can contribute to this exciting field. Remember, every time you use an electronic device, there's a complex world of PCBs working tirelessly behind the scenes.